All right, we got lesson 2.1.4. This one's called y equals mx plus b. Okay, so y equals mx plus b is the equation of a line. So in that equation of a line, we've got a couple different things. First of all, we've got things called variables. Variables are our x and our y, and these are our inputs and outputs. Now they're called variables because they can change. Because we know that when we plug in an input, a lot of times we get another output. So that means these are going to be changing all the time. They're variable. Variable means change. Next, we have something called parameters. Parameters are m and b. So in this one, our parameters are m and b. And a parameter is something that doesn't change. So for any specific line, so if I'm thinking of one line, it's only going to have one m value, and we found out that m is the slope. And it's only going to have one b value, and we've said that the b value is the starting value, which could also be called the y-intercept because it's when the x value is 0. So those are parameters. They're not going to change for any specific lines. So if you've got a specific line, there's only going to be one m and one b, but the variables are going to be y and x because you can plug in an x and get a different y. It's going to keep on changing. Now we also call the m the coefficient. The coefficient is something that's multiplying by a variable. So in this case, m is multiplying by x, so m might be 2, so the coefficient would be 2. b is a constant because it's not being multiplied by something else. So coefficient is when it's multiplied by a variable. And constant means it's just a number that doesn't change. All right, so we also call this y equals mx plus b slope-intercept form. So that's slope-intercept form for a linear equations. So equations that make lines. Okay, so what effect does m and b have on a line? Well, we said m was its slope. So m is the slope, and it tells how steep the line is. And we said that slope was steepness. And we said b is the starting point, which also means that's when x equals 0. So you plug in 0 for x, and then you get the y value, which is going to be b. And we also call this the y-intercept. So knowing those two things, we can write any linear equation. If we've got the slope and we've got the y-intercept, we can just plug in m for the slope and b for the y-intercept, and we've got the equation of the line. All right, so we've got a little thing here. I don't know, maybe one of your parents works in a company that does like work that's like not off the shelf. So they're working for a company that makes stuff to order. So they don't just make a product that people pick up off the shelf. People come to them and say, hey, I want this done. And then they have to make it to the customization of whatever the customer wants. So that's kind of a tricky job because sometimes, people say the customer's always right. Well, a lot of times the customer's wrong because they don't know what they're talking about. And talk to your parents about that. I'm sure they have some really good stories about customers who didn't know what they're doing. But anyways, we're going to pretend like we have a factory that makes lines to order. So people come in, they tell us what we want, and then we make the line for them. So we're going to see if these customers are giving us enough information to actually make a line. So customer A, they come in and they ask for a line that goes through 2, 5. So if you have graph paper, you can graph this out, or if you have from my Google Classroom, the resource page, you can print that off and just use that there. But if you don't have the resource page, it's fine. You can just use some graph paper. So here we go, line A. We've got the customer, they come in, they ask for a line that goes through 2, 5. All right, so the line is going to go through 2, 5, right there. Well, they gave us 1 point. Is that enough to write the equation of the line? Well, maybe. I mean, I could make a line here that goes through 2, 5. So there's a line that goes through 2, 5. The only problem is I can make another line that goes through 2, 5. And I can keep on doing that. What if they wanted a horizontal line that goes through 2, 5? They didn't say. I could make it for them. This customer, I have a feeling, had a very specific line in order, but the information, a line to order, but the information they gave us wasn't enough for us to figure out which line they wanted. So we can't write an equation for it. So we can't produce the work that they wanted because they didn't give us enough information. So we're going to say right here, thanks for your business, but you're going to have to give us some more information. Sorry. All right, next one. We've got a customer who comes in and asks for another line. So this is line B. And they say that they want a line that has a slope of -3 and they want it to go through the origin. All right, going through the origin means one of the points is 0, 0. Ooh, they gave us the y-intercept right there. That's kind of nice of them. And then they want a slope of -3. Now, -3 means that the slope is -3 over 1, because slopes can always be written as ratios, which means fractions. So my change in my y value is -3, and my change in my x value is 1. So I'm going to go down 1, 2, 3, and over 1. Well, that was nice of them because now we can actually draw a line. You need 2 points in order to draw a line, and they gave us the 2 points. They gave us the origin, which is 1 point, and from the origin, we can use the slope to find the second point here by going down 3 and over 1. So, do we have enough for an equation? Yes. We do. Y equals m is the slope they gave us, which was -3. And that's the coefficient in front of x, the other variable. And then it would be +0 at the end because it went through the origin. The origin is the y-intercept, and this one intercepts the y-axis at 0. So I can do +0 here, but I don't need a +0. I'm just going to leave it blank. So anytime there's something blank in the end, that just means zeros right there. All right, another customer comes in. Looks like it's a busy day in the line factory here. This customer wants a line C, that goes through 2 points. Let's see if that's enough information. So the first point's at -3, 2. So I'm going to go down 1, 2, backwards, 1, 2, 3, and down 2. So there's my first one. And then it's going to go through 3, 10. So 3 and then 10. Almost made a big mistake there, but I recovered. All right, so we've got a line that goes through those 2. All right, then I'm going to write my equation. Okay, I'm going to stop here. I'm going to show you the rest of the orders. We've got a lot of them. Here's the rest of the orders. So we're in the middle of doing C, and I want you to find the equation of that line. Then you're going to do D, and this customer says, hey, I want a line that goes through these points. So you're going to use those points to draw the line. Then I have a customer who wants a slope of 4. I've got a customer who wants to go through the point 8, -1, and have a slope of -3/4. And then the last customer gives you this table to graph your line and find an equation. So finish it off, graph each of these lines, and then if they gave you enough information to actually draw one single line from what they gave you, then write the equation for it. So finish out the equation for C, and then do D, E, F, and G. Okay, I'm going to pause here for a second in 3, 2, 1. So pause your screen, and then we'll see what we got. All right, so let's look through these orders that we have here. Here's C. So I came up with the equation y equals 2x plus 4. Okay, how did I get the 2? Well, it was going up 12 for my change in my y over my change in x is positive 6. So 12 over 6 reduces to 2. So that's why I have 2x there. How do I find the plus 4? Well, I can go over here to the y-intercept and see that it's 4. I can even double check it if I know that it's going up 2 over 1, up 2 over 1, up 2 over 1. I can keep on doing the slope triangles from this point here to this point here and see that it crosses at 4. I can just make those slope triangles and go up 2 over 4, up 2 over 4, and so on and so forth. See, like this. Up 2 over, oh, sorry, up 2 over 1. What was I thinking for? Up 2 over 1, and then up 2 over 1. And we just kind of make those stair steps, and we see that it crosses right here at 4 when we do that. The next one, I forgot to write negative over here, so I had to scratch those out. Next one, they gave us the points. They gave us some points that were fractions, so it kind of gave us a little bit of a problem there, or decimals. And here's what I did to kind of fix that, is I noticed that they were all going by 2.5. So I could have said that as the x is increasing by positive 2, the y is increasing by positive 5. And there we get a nicer slope than 2.5 over 1. We usually don't want fractions or decimals inside of our fractions. So going back to part, which one was that? D. Going back to D, that's what I did, is I picked the two that we call these lattice points because they cross at whole numbers. So I went over 2 and up 5. So my change in y is 5. My change in x is 2. So that's 5 over 2. And again, if I keep on doing these slope triangles, I can see that the slope triangle going backwards, if I go backwards 2, I'm going to go down 5. And that crosses the y-axis at -4 right there. So y equals 2.5x minus 4, or 5/2 x minus 4. Next one, all they gave us was the slope. So I could have started anywhere. And so I showed you that, showed here where I have 3 different lines all with the same slopes. So if they're looking for a specific line, they did not give us enough information for that one. Next one, what did they give us for F? They gave us just 2 points. No, a point and a slope. So they gave us the point 8, -1 with a slope of -3/4. So from 8, -1, I went down 3 over 4. And you can see that I made some more slope triangles back here. You can go backwards 4 and up 3, backwards 4 and up 3, and then you end up finding where it crosses the y-axis, the starting point, or the y-intercept, which is positive 5 when you do that. So y equals -3/4 x plus 5. The last one, they gave us points on a table, and they didn't even make a line. So that customer, I don't know what they were wanting, but they went to a line factory, and they did not even ask for a line. Fools. So, didn't ask for a line, so we can't make a linear equation after it, since that's not a line. All right, going back to our work here. So we've done that. All right, let's say that we've got Gloria, and she ran out of graph paper, which I'm sure has happened to you at some point. But she wants to know the slope of a line that passes through 2 points. What can she do to find the slope of the line? She's only got the 2 points, no graph paper, and we're going to say that she doesn't want to draw on a piece of paper or a graph and have to do that because that gets messy. So can we do it without it? Sure we can. Remember, slope is the change in the y divided by the change in the x. So how much is are the y values changing from 5 to 7? Well, from 5 to 7, it looks like the y values are changing by +2. How much are the x values changing? They're going from 6 to 3. That's subtracting 3. So +2 over -3 is -2/3. So what else could we do instead of just finding the change? Well, the change can also be called the difference. And difference means that you subtract. So I could have, instead, when I did my change in y over my change in x, I could have subtracted the value. So I could have done 5 minus 7 over 6 minus 3. And that gives me -2 over +3, which is what I got over here. What if I did them in the other order? What if I went from 7 to 5 and 3 to 6? Let's see what that would have given us. If I did 7 minus 5 over 3 minus 6, because the change is the difference in the x and the difference in the y. So I get 2 over -3, which we already said was still -2/3. So no matter which way I do it, if I just look at the change going to each of them, or if I look for the difference, and difference is the change, I still get -2/3 any way we do it. All right, now it's your turn. Find the slope of these two lines. So we got one going through 415 and 211. Find the slope of that one. Next, we've got the slope of the line going through 2886 and 3483. This is a problem where you don't want to graph these. I mean, this is way too far away from the origin. Your graph would have to be huge. So you definitely don't want to graph them. So instead, go ahead and use the subtraction method to find the change or the difference in the y and the x. I'm going to pause real fast, write down your answers, and we'll check to see what we got. I'm going to pause in 3, 2, 1. All right, pause. All right, we are back. So I went ahead and subtracted 11 minus 15. You could have done 15 minus 11 and then 4 minus 2. Would have given you the same answer as we showed up here. So I did 11 minus 15. So I got -4. And then I did 2 minus 4 and got -2. So -4 over -2, a negative divided by a negative is a positive. So my slope is +2 when I reduce that fraction. For the next one, I did 83 minus 86, which is -3, and then 34 minus 28, which is 6. -3 over 6 reduces to -1/2, and there's our slope without having to graph it. Last, what is the steepest line possible? What's the slope going to be for the steepest line that you can think of? All right, so think of what the steepest line would be and what would be its slope. You got it? Steepest line. The steepest line would be perfectly vertical. All right, and what did we say about vertical lines? We said vertical lines have no slope at all. It's so steep that it's impossible to say it. So we either call it no slope or we say that the slope is undefined. I think this textbook is going to lean upon undefined. Undefined just means that you can't write it out, because remember we said when we have the slopes of those vertical lines, we always get 0 in the change in the x, and you can't have 3 pieces of nothing. So that's why we say undefined, is you can't really state what that number is because it doesn't exist. You can't do 3 divided by a 0. You can't divide anything by 0. So that we would say no slope or undefined also works. All right, we are down to the very last. We're going to look at our methods and meanings for today. So, move this over here. We're going to talk about the slope of the line, which we've just been doing. So when we talk about a slope of the line, it's always going to be a ratio. The slope is a ratio. Ratio means fraction. So our slope is always going to be a ratio, which looks at the vertical distance, which is the change in the y, and compares it to the horizontal difference. So we've got vertical change over horizontal change, change in y over the change in the x. All right, so if it slants up, we know that it's going to have a positive slope. If it slants down, we know that it's going to have a negative slope. A horizontal line, that's a completely flat line, has 0 slope. And then we just said in that last problem that a vertical line has an undefined slope. And now we've seen that we don't need to be looking at a graph in order to find a line slope. We can instead subtract the y's and subtract the x's to come up with our slope. So if we have 2 points on the line, then we can draw a slope triangle in a graph to find that. Or we can instead find out the change in y and change in x by subtracting. Up here, we've got the 5 minus 3, and then 3 minus negative 2. So 5 minus 3 is the positive 2 on top. And then 3 minus negative 2, a negative is a positive, so this would be 3 plus 2 to give us the 5 on the bottom for the slope. All right, that's all I've got for you today. Enjoy. See you next time.